As we examine the various ways that molecules can interact with one another and the resulting behaviors of the substances on the macroscopic scale, we will want to make a distinction between cohesive forces and adhesive forces. The intermolecular forces we have learned thus far, when occurring between molecules of a substance, are cohesive forces. These are attractions that molecules can exhibit between one another that cause cohesion in a substance, which can be extreme for a very viscous substance. In a liquid, these cohesive forces are felt equally in all directions by most of the molecules, but not for molecules that are at the surface of the liquid. These molecules only interact with half as many molecules as the rest, because they are at the edge of the substance. This is why liquids tend to contract to form shapes that minimize their surface area. We can see this in a drop of water, which will be roughly spherical. The sphere is the shape that minimizes surface area, so a water droplet will adopt this shape to maximize the hydrogen bonding that is occurring in the droplet. Of course, if this droplet becomes larger, other effects like gravity and air resistance come into play, and it will not remain spherical for long. But in a tiny droplet, we can see this effect quite pronounced. The interactions between liquid molecules and some solid surface are called adhesive forces. These describe the ability of a liquid to adhere to that surface. Take water, for example. If we place a drop of water on a piece of plastic or some other surface that won't interact with water, the water will not wet the surface, and it will retain a spherical shape. This is because the cohesive forces, the hydrogen bonds occurring inside the droplet, are stronger than the adhesive forces between the water and the surface. But if we place a droplet on glass or another surface that will interact with water, it will spread out and maximize interactions with that surface, because in this case, the adhesive forces are stronger. We can see this happening when we place liquids in a glass tube. Because water is attracted to the glass, it will form a concave meniscus, meaning the surface will curve downwards. This is because it will allow water to maximize its interactions with the sides of the glass tube. If we try this again with mercury, it will look different. In mercury, the cohesive forces between the mercury atoms are stronger than the adhesive forces between the mercury and the glass. So mercury will form a convex meniscus, which is when the surface curves up like this. It will do this so as to minimize interactions with the glass, which in turn maximizes the interactions between the hydrogen atoms. This is why the mercury in a thermometer is curved in this manner. And now we can differentiate between cohesive and adhesive forces.